Imagine you're hiking in the woods, and suddenly, you hear a loud growl behind you. Before even consciously thinking about what to do next, your heart begins racing, your breathing speeds up, and your muscles tense. Within seconds, your body is preparing either to escape the danger or confront it. This automatic reaction is known as the fight or flight response, one of the most important survival mechanisms humans possess. The fight or flight response is controlled primarily by the sympathetic nervous system and involves the rapid release of hormones such as adrenaline, also called epinephrine, and cortisol. These physiological changes help the body respond quickly to threats and increase the chances of survival. Today, I will explain how the fight or flight response works, why it evolved, the scientific evidence supporting its importance, its real-world applications, and what scientists are still learning about this remarkable biological adaptation. How the fight or flight response works. The fight or flight response begins in the brain. When a potential threat is detected, the amygdala, a structure involved in processing emotions and fears, rapidly evaluates the situation. If danger is perceived, the amygdala sends signals to the hypothalamus, which acts as the body's command center. According to the National Institute of Mental Health, the hypothalamus activates the sympathetic nervous system, triggering the adrenal glands to release adrenaline into the bloodstream. Adrenaline causes several immediate physiological changes. Heart rate increases, blood pressure rises, breathing becomes faster, pupils dilate, blood flow is redirected from digestion to skeletal muscles, and glucose is released into the bloodstream for quick energy. These changes prepare the body to either fight the threat or flee from it. At the same time, another system, called the hypothalamic pituitary adrenal axis, or HPA axis, releases cortisol. Cortisol helps maintain energy supplies and keeps the body alert if the threat continues. Together, these responses allow humans to react within seconds, often before conscious decision-making occurs. Why did the fight or flight response evolve? To understand why the system evolved, we must look at the environments our ancestors faced. Early humans lived among predators, harsh environments, and dangerous conditions. Individuals who could respond rapidly to threats were more likely to survive and reproduce. Through the process of natural selection, beneficial traits became more common in a population over generations. The fight or flight response provided a significant evolutionary advantage because it increases the likelihood of survival during dangerous encounters. Faster reactions meant a greater chance of escaping predators, defending oneself, protecting offspring, and securing resources. According to evolutionary biologists, many of the neural pathways involved in stress responses are highly conserved across vertebrate species, suggesting that these mechanisms evolved millions of years ago and have remained important throughout evolution. The fact that similar stress responses are found in mammals, birds, reptiles, and fish demonstrates how effective this adaptation has been for survival. Scientific evidence supporting its importance. Research strongly supports the importance of the fight or flight system. One of the earliest scientific descriptions came from physiologist Walter Cannon in 1915. Cannon observed that animals exposed to threats experienced predictable physiological changes that prepared them for action. He coined the term fight or flight and demonstrated that these reactions improved an organism's ability to survive dangerous situations. More recent research has expanded our understanding. A review published by Harvard Medical School explains that activation of the sympathetic nervous system rapidly mobilizes energy, increases oxygen delivery to tissues, and improves physical performance during emergencies. Studies using brain imaging techniques have shown that the amygdala can process threatening stimuli extremely quickly, allowing protective responses to begin before conscious awareness fully develops. Research published in the scientific journal Nature Reviews Neuroscience also shows that stress response systems are deeply integrated into survival behaviors and have been preserved through evolutionary history because of their adaptive value. These findings support the idea that the fight or flight response is not simply a reaction to stress, but a highly refined evolutionary tool that has enhanced survival for countless generations. Real-world applications and significance. Although humans no longer face predators on a daily basis, the fight or flight response remains extremely important. In emergency situations such as car accidents, natural disasters, fires, or medical emergencies, this system can save lives by improving reaction time and physical readiness. The fight or flight response also plays a major role in medicine and psychology. Doctors study stress hormones to better understand conditions such as anxiety disorders, PTSD, panic disorders, or chronic stress-related illnesses. Understanding the biology of the stress response has helped researchers develop treatments that improve mental health and overall well-being. The fight or flight response is also important in sports and athletic performance. Moderate activation can increase focus, reaction speed, and physical output during competition. In military training, law enforcement, and emergency response professions, understanding how the body responds under stress helps individuals perform more effectively during high-pressure situations. These examples demonstrate that an evolutionary adaptation developed thousands of generations ago continues to influence human survival and performance today. Limitations and ongoing research. Although the fight or flight response is highly beneficial, it also has limitations. The system evolved primarily to respond to immediate physical threats. However, many modern stressors, such as exams, work deadlines, financial concerns, and social pressures, activate the same biological pathways. Unlike escaping a predator, these stressors may persist for weeks or months. Chronic activation of the stress response can contribute to health problems such as high blood pressure, cardiovascular disease, anxiety, depression, and weakened immune function. Scientists are still studying important questions about the stress response, such as why do some individuals experience stronger stress responses than others, or how do genetics influence stress resilience? These unanswered questions remind us that science is still an ongoing process of discovery. In conclusion, the fight or flight response is one of the most important evolutionary adaptations in human biology. By rapidly activating the sympathetic nervous system and releasing hormones such as adrenaline and cortisol, this system prepares the body to respond effectively to threats. Through natural selection, individuals with faster and more effective stress responses were more likely to survive and reproduce, allowing this trait to persist across generations. Scientific research from neuroscience, physiology, and evolutionary biology continues to demonstrate the critical role of the fight or flight response in survival. Even today, this ancient adaptation influences emergency responses, medical research, athletic performance, and mental health. The fight or flight response is more than just a reaction to danger. It is a powerful evolutionary tool that has helped humans survive for thousands of years and continues to shape our lives today. Thank you for listening.